live. There we go. Okay, so you guys have seen this before. The top part of any fractional exponent, so what we're talking about is rational exponents. And that word rational, that word pops up on the SAT. Most kids are like, what do they mean? What is rational? It's just a fancy word for fraction. Any number that can be a fraction is a rational number, okay? So the word rational just means fraction. Okay, just off on a tangent, for example, 2/3, 5.3, 0.6 repeating. All of those numbers are rational numbers. They're all rational numbers because they all can be a fraction, right? 5/1, right? 3/10, right? That's 2/3. So we agree with that? So all of these are what we call rational numbers. Okay, now numbers that are not irrational, or that are not rational, are called irrational numbers. Irrational. Pi square root of 2. These are numbers that the decimal goes on forever. So does that one. But these never repeat. Does that make sense? Square root of 2, ugly decimal, 1.41, blah, blah, blah. It's a decimal, goes on forever, but it never repeats. It's irrational, and these are rational. So this exponent needs to be a fraction. It's a rational exponent. So what we've learned from way back when, before COVID, is that the bottom number is the root, and the top number is the power, okay? Now, some of these you can do on a calculator. If it's just plain old numbers, you can just type it in. But I'd like us to learn how it works. So, example 1a, I talked to you really quickly about the fact that anything to the 1/2 power is the same thing as square root. There's an invisible 1 here and an invisible 2 here. So it's just 3. B, because of the negative, it's going to be 1 over cube root 8 squared. 1 over because of the negative exponent, cube root 2 squared. Now, you've got two choices. You could square it, make it 64, and then figure out what the cube root is, or the easier way is cube root this first, makes it smaller. Cube root of 8 is 2, and 2 squared is 4. See that? Much easier to make it smaller instead of bigger, right? So I'm going to rewrite this as 1/4. Okay. C, it's the same as the cube root 27x to the 6th. 27 is a perfect cube root, 3 times 3 times 3. And I think it's really easy to show it this way, that you take 1/3 of the exponent. You can see that it's 1/3 of the exponent from that, right? So you take 1/3 of the exponent, you get x2. Because x squared makes x to the 6, doesn't it? Yeah. I know, this doesn't have to be hard. B just says rewrite. That's all you got to do. So rewrite is just going to be the 4th root of x cubed. That's all.
I'm curious, is there any time you can like cancel the whatever root you're finding and the exponent? Like, can you like, I don't know, like if just say you were at like the 4th root of x squared, could you like, is there any way you could like cancel the 2 and 4 or something like that?
Yes, and that happened. Really good question, because you're going to see that in your homework today. That's the same as x to the 2/4, which is the same thing as square root of x. This and this are the same thing, because you reduce 2/4 into 1/2, right, Lauren? Good answer. Okay, now let's take a look at B. I'm going to have the square root of 6 over the square root of x. I go too fast on that? Negative, I brought it down. Or if I wanted to do it this, I could rewrite it like this. Either answer is fine. Okay? C. Well, we have to add exponents. So I need a common denominator. On C, I'm going to rewrite this as y to the 2/4 times y to the 1/2 because I needed a common denominator. Oh, no, I did that wrong. I got it backwards. Oh, my goodness. Yeah, 1/4 and 2/4. There we go. That's what I meant to do. I was thinking ahead of myself. Now, does that make sense?
Yes.
Thank you. And that's just y to the 3/4. Now, they want it in radical form, so I'll rewrite as the 4th root of y cubed. B just says rewrite in exponential form, so we'll just do the opposite. Remember, there's an invisible 2. We don't really need it, but there's an invisible 2, so it's just going to be z to the 5/2. All right, let's simplify this as much as we can. This is going to be a 27 x to the negative 3 y to the 6 to the 1/3 power. But we can do more. We can do more. 27, cube root of 27 is 3. I'm going to multiply exponents, right? Let's multiply exponents. So I get an x to the negative 1, y to the 2, and I may as well just rewrite it with the x down below. 3y squared over x. C is a lot like the one above it. A lot like it, okay? Am I going too fast or am I okay? I'm okay. All right. Lauren, I'm okay. Everybody else, I'm okay. Tanya, how am I doing? Okay. So x to the 1/4 times x to the 1/3. I have to, again, add exponents. So I'm going to get a common denominator of 12. X to the 3/12 times x to the 4/12, right? Now I can add my exponents. Get x to the 7/12. Not too bad. 4, I'm just going to distribute, but again, I add exponents. So I'll distribute this times this, this times this. I'll get an x to the 4/2, which is 2, minus x to the 0, which is the number 1. So I'll have x squared minus 1. Am I doing all right? You guys remember this from far back and away? No? Okay, well, it's a good day to relearn it. Okay, now, B, there's an easy way and there's a hard way. I'm going to show you what I see to make it easy, okay? First of all, 2 over 2 just cancels. You okay with that? Because of the multiplication and the division, I can do that. Now, the next thing I'm going to do to make it easy is I'm going to bring up the x to the 1/3. I'm going to bring this up because of the negative. So I'll rewrite this as a x to the 1/3 times another x to the 1/3, right? Because I brought the 1 up.
Someone just died.
Is that in Betsy's class or something?
Probably.
Okay, now 1/3 plus 1/3 is 2/3, right? I'm going to add exponents. I'm going to get an x to the 2/3, 3x to the 1/3 plus 4x to the 4/3. All I did is I just added my exponents. Okay, that's all I did. And now I'm going to distribute and add exponents. This times this times this, and just simplify, right? I'll have a 3x to the 3/3
plus a 4x to the 6 thirds. Oh, I guess I could squeeze it in under it. Or 3x to the 1, but that's just 3x, plus 4x squared. That's it. Okay, these aren't so bad, are they? Okay, turn the page. Okay. All right, now, solve for x. Don't divide by 8, divide by 8, because this is 8 to the x.
You got the convert it.
Yeah, convert it. In fact, let's change with the same base. We want the same base. So the base is the number. So b to the x. The base is that number, okay? So what's a good base between these two?
4,
Go lower.
2.
2. Because you can't change 32 into a 4, right? But you can go a 2 cubed equals a 2 to the 5th. No 4 to no power will equal 32.
Yeah.
Well, you'd have to have a decimal number, right? Okay. And since it's 2 to something, it really means just 3x equals 5, right? Divide by 3, and x equals 5 thirds. I like these. These are kind of fun, aren't they?
Yes, sir.
Yeah. So what do you see about b? What do you think? Same base?
5.
Yeah, base 5. 5 to the x equals 5 cubed to the x plus 1. Pretty good, 5 cubed? 5 cubed is 125. It's 5 to something, boom, boom. X equals 3x plus 3. I skipped a step, but I think you guys can obviously see that, right?
Plus 1. Oh, the 1.
It's okay. No, Greer, always question me because I always make mistakes, don't I? Minus 3x, negative 2x equals 3. I skipped a step. I skipped a step, right, Greer? Divide by negative 2, and there's my answer. Okay? All right, what do you think about 8? Or C, I'm sorry. What do you think about C? Base what? What base should we make?
Base 2.
Base 2. 2 to the 3rd, right? Because that's 8. Equals 2 to the 5th times 2 squared. Okay? So 4 is 2 squared, 8 is 2 cubed. Thumbs up? Right? Right. Now, this is 2 to the 3x equals 2 to the 5th times 2 to the 6x. This is where you have to put on your thinking cap. When you multiply bases, you add exponents. I have to add these two exponents to make it 2 to something. This is going to look weird, but this is exactly what it is. This is 2 to the 5 plus 6x. Because I added my exponents, okay? So, on a side note, so it totally sinks in, x cubed times x squared, what do? It's x5, right? But then you write it as x5, right? Same thing. 2 to the 5th times 2 to the 6th is going to be 2 and add exponents. Does that help? Okay, and then, now you can cancel out the 2's because 2 to something equals 2 to something. I can cancel out the 2 to somethings. Cancel that, I don't need that anymore. And then I'll have a 3x equals a 5 plus 6x minus 6x minus 6x. I'll have a negative 3x equals 5. Divide by negative 3, negative 5. That was a good problem. I like that one. Okay, I'm getting there. All right. D. What's my base? What's my base?
9.
Not 9, because I can't. 9 to what power won't make 27? Does that make sense? 3. Let's go 3.
3 to the 3 to the third, 1 minus x, equals, you ready for this? Well, let me do it on the side. Let me just do it on the side, because I don't, so, you'll see it.
Would you use negative?
Yes, yes. Thank you, good job.
Yeah.
So it is 1 over 9 is the same thing as 1 over 3 squared, the same thing as 3 to the negative 2. You okay with that? Does that make sense? So we're going to make this a 3 to the negative 2 power. Okay. Okay.
I know this class makes you think too hard, doesn't it, sometimes, huh? I know, indeed.
Yeah.
Kai, I know you like the weight room. You're doing double duty because you're hitting the weights heavy in math for your brain. Heavy in the weight room. 3 minus x. So here is my 1 over 9. So 3 to something, I got 3 times a 1 minus x. Negative 2 times a 3 minus x. 3 minus 3x equals negative 6 plus 2x, right? Plus 3x. 3 equals negative 6 plus 5x. Plus 6 plus 6, 9 equals 5x. Divide by 5 and I get 9 fifths. I didn't go too fast, did I? A little bit, okay. Tell me to slow down.
Oh.
I'll let you catch up. I mean, the solving for x is pretty easy for you. I just went through it kind of fast.
Oh.
Do you see it, Carly?
Yeah.
Okay, you ready for a 7? We learned this equation. A of t equals A0, 1 plus or minus, but this is growth rate, I'm going to go plus r to the t power, okay? If it's decay, it'd be minus. And what I want to find, it seems like I want to find the growth rate. I want to find r, right? So the house was bought for $250,000. That's got to be my initial part, right? So I'm going to go 250,000 here. One plus, I don't know r, but how many years did it go?
10 years?
10 years. I'll put 10 for t. And in the end, we sold for 400,000. Boy, it sounds like this area, doesn't it? Sounds like Leavenworth these days. Okay, now.
You have to reverse.
Yeah, let's reverse it, solve it. So what's the first step we should do?
Divide by.
Yep. Cancel. What's 40 divided by 25?
Awkward.
40 divided by 25 is 1.6 equals 1 plus r to the 10th. Now what are we going to do? 10th root of it, right? Now, I don't know how good your calculators are, but I'm telling you, my calculator will do it. So if I go to math, the math button, and you can do an any root. See my any root button? Went to my math, I hit math. Here, I'll quit it again. On my calculator, I went to math. I went to the any root, okay? So I'm going to go 10, math, any root. See, it makes 10th root right there of 1.6. And I get 1.048. 1.048 equals 1 plus r. Minus the 1, I've got 0.048 equals the r, but as a percentage, right? We're just going to make that 4.8% over 10 years. How's that? Okay, now, Kai, why don't I reduce this a little bit?